Hello and welcome to Extreme Academy Live. This is where you come to advance your knowledge, advance your skills, and advance your prospects. Now remember, at the end of this series of live streams, you'll get access to an exam. It's completely free of charge. If you pass that exam, then you'll get a certification from Extreme Networks. You can put that on your resume, and it's going to help you advance your career. Now we're into week 5 now. These weeks are flying past now. I'm going to bring in Isaac. Isaac, before we introduce this week's session, I spotted something new on your shelves. Looks like you've got a new model, a new car. What is that?
Yes, absolutely. That's a good spot. So 2 weeks ago we had an Italian on the show, Guglielmo Marconi. Today we have another Italian on the show, Mr. Enzo Ferrari, the Enzo Ferrari. And guess what he said of that car? He said, "This is the most beautiful car that's ever been built." And guess what? It's not even Italian, it's British. The Jaguar E-Type, absolutely fantastic model. Thank you, good spot.
Yeah, absolutely beautiful car. And Isaac, you mentioned Marconi there. We should say happy birthday, right? A few of our viewers put it on social media, they knew as well, but last weekend it was Marconi's birthday. You talked about him last week in the break, so let's say happy birthday to Marconi.
Happy birthday, Mr. Marconi.
So Isaac, what do we got on this week?
Okay, so we got 3 things that came from our weekly meeting. The first one is the great news, right? Today we're doing 802.11ax, and we have a special guest. I'm not going to tell you. You stick around. I mean, you know what it is, but stick around. We've got a great guest coming on. It's going to be fantastic. Secondly, I wanted to talk about Discord. So we've been talking about Discord already internally for a while, but 2 weeks ago or last week we had this impetus. Okay, let's get this going. It's always been my desire, I suppose, to build a community around Extreme Academy, right? Within this period of time, this 2-hour slot that we have, we can interact kind of in the chat window, and then after that it's gone, And so I've always felt that there's a need, and I can see from people who contact me on LinkedIn that there's always people who have further questions, and it's kind of, where do you go? So we've decided to go ahead with it. We've already created a Discord channel for Extreme Network. It's not public, so you can't, just search for it and find it. We've created it. It's up and running. We've got... we're in the process of recruiting some moderators. We've got one moderator already that's going to be helping us. The main purpose of this is for us to share content, to share ideas, to share support each other for people who want to learn more, right? I want it specifically to be, there's one thing I want that in Discord that's different to everybody else. Well, I think so. And that is, I want to make it a safe space. I want it to be a safe space for anybody of any knowledge level to come in and learn. If you are one of those people who you're scared to ask on the YouTube chat because maybe you just don't know a lot and you're scared, you feel embarrassed that, what will people say? He told me that, but I don't understand. Then Discord channel is for you. Discord channel is for you to come in and just ask, and not feel embarrassed, not feel shy, just ask, and there will be people around there, maybe not immediately, but we hope to have people around the clock from different time zones to be able to share knowledge, to be able to, without judging, without pointing fingers and say, oh, we already talked. No, just an open, free space where we can share ideas, put homework, have interactions, possibly have, audio conferences on there where we chat and teach and stuff like that. So that's coming up. You're going to see the URL coming up below, and you're going to see the QR code coming up, I think, on somewhere in the background around about now, and possibly, no, not possibly, during various times during the teaching, that's going to pop up as well. Just scan it. Your camera will detect the QR code, take you to the App Store where you can go and download it, and then that invite will take you directly into our channel. So it might not be active right now while we're doing the 2-hour, but it's open and available, but there might not be a lot of chat. I'm not too sure on there. So please feel free, join us on Discord, tell friends about it, and let's build a nice community, a nice, safe community. So that's the first thing. And then the second thing was, I got some comments last week about the episode that we had, Series 4, because it wasn't really technical, but it doesn't mean, and it wasn't negative comments, it was just, wow, this one was different to the other, but it's still important, right? So I'll hand that one over to you and you can talk about that a little bit.
Yeah, Isaac, there's a balance, right? We all want to know the technical details, we want to learn technical information, but in Extreme Academy we're going broader than that. We want to equip people with the knowledge and the perspectives and form some opinions that are going to help develop your careers, maybe even help you get a job. And to do that, you need a broader understanding of the technology and the way it's used. And when we interview people at Extreme, and it's the same with our partners and with our customers, when they interview engineers and when I interview engineers, I don't just want to see whether somebody knows the technical bits and bytes and they understand how everything goes together. I want to know that they understand the context that system is going to be used. So do you have a perspective on the business outcome that the business stakeholders in an organization are looking to achieve? That's really important, and you need to have a perspective on that, because somebody might ask you in an interview, and if you can give a good answer to those types of questions about the planning, the design, the business aspect of a system, if you can give a good answer to that, then you're going to stand out from all the other people that are going for that job. And you might be equal from a technical perspective, but if you've got a good outlook on the wider picture, then that's going to be really important to your success moving forward. And that's what we're trying to give you with Extreme Academy. So there's a perspective on that, Isaac. I just wanted to share that with everybody. Okay, we're ready to go now. So Isaac, over to you. Let's do week 5.
So like we said in the intro with Rowan, we do have a guest. We do have a guest speaker today. When I left my previous company, I moved to Aerohive, right? So I'll tell you a little story here because it's relevant. You remember last week I encouraged all of you to get LinkedIn accounts, right? And I told you about my experience of when I traveled around the world teaching, that oftentimes I would, before I would start a class, like I would fly out of the UK, say on a Friday morning or Friday evening, maybe arrive at my destination on Saturday morning, or most times I'd like to arrive at my destination on the Friday evening. Then I could sleep in late and have a good sleep on the Saturday morning. And then I would often do is I would ask the customers just to let me know who the students who would be attending, and then I'd go and look up their names and go and look on LinkedIn just to get a better idea who it was that I would be teaching. And it always surprised me how few engineers were on LinkedIn, and especially in Asia, I found that really, really quite strange. And so I was approached because of my LinkedIn profile. Someone in Silicon Valley, a lady working for Aerohive, she was looking for a technical trainer, and she typed in and my name came up and she contacted me, and I ended up at Aerohive because of a tool like LinkedIn that uses networks, right? So I ended up at Aerohive, and when I joined Aerohive, my first boss was our guest who's going to be on today. And when it wasn't supposed to be like that, it was supposed to be somebody else. But then when they gave me the job, they said, oh, by the way, the guy who was going to be your boss has been moved to a different division. So this guy is your new boss. And I immediately did what I tell you to do. I went onto LinkedIn. I went to go and check who he was. And I went like, oh, wow. Oh, wow. I really like this. I really like this. And then, we had a couple of chats, on the phone as I got started in my job. And then I went to visit him in Atlanta, Georgia. And I spent a week in Atlanta with him, learning a lot from him within that week. And then life is really interesting, right? A couple of weeks after that, I don't know, it was about 8 weeks or something after that, Extreme Networks acquired Aerohive technology, right, and bought out the company. And here I am today with Extreme Networks. So the world is a really interesting place. The guest that I have on today is a pretty amazing guy. He won an award, I think it was last year, for somebody who has contributed to the Wi-Fi community tremendously over the last few years. So his official title is a Director of Wireless Networking, and he works for the Office of the CTO, Chief Technology Officer. If you guys remember that podcast that I told you about, Inflection Points, that's run by the Office of the CTO. So there's a small group of highly qualified, highly intelligent engineers that work within that CTO, and he is one of those people. Ladies and gentlemen, I'd like to introduce you and to somebody who's become my friend. We have regular meetings. A man who knows tons about Wi-Fi networking, David Coleman. So I know he can't hear you, but just put your hands together, say, welcome, David Coleman. David, thank you so much for being for coming on Extreme Academy. I value your time. I know you're a really busy person and you know tons of stuff. I know the level at which you talk to all the people that you talk to around the world. Extreme Academy welcomes you. We're a community of people wanting to learn. This is our second course, as I'm sure you're aware of, on wireless. We've done 4 episodes already, or four lessons already. Last week was a lesson on designing networks, right? And it was about how you think about this, how you got to document this, how you got to plan, how you got to do site surveys, how you got to do all of those things to roll out a successful wireless network. So it was interesting. Was a little bit dry. It wasn't a lot of technical stuff. But today we're going to be talking about Wi-Fi 6, which is, I know, one of your specialities, and I know that you have a book as well, a dummy's guide to Wi-Fi 6. So David, please feel very welcome, because that's what you are. Very welcome to be with us, and let's get into the first question. Just before we go into that, just to let you know that within about 20 minutes of us starting, we have this little thing that we've started in the wireless course, where we have a 1-minute break just for people to get up and stretch. So you'll hear me at one point in time. I'll just say, okay, hold your horses, time to get up, time to stretch, and we'll just hold it for 1 minute. We'll have a video clip on. Also gives you time to get something to drink, a glass of water, or have a sip of water, whatever. Get up and well, you're up already. Just have a stretch, and then we'll go straight back in. Other than that, I'll tell you when we get to a break. We have a 10-minute break, and then after that we'll have another 1-minute break. But I'll let you know about that. So David, thank you very much. Glad to have you here.
I'm glad to be here. Thanks for having me, Isaac.
So today's topic for the class over here, for everybody over here, is we are talking about 802.11ax. Now, we've already covered lesson 1, 2, and 3. We have spoken at various times about the different standards of wireless, right? We already know 802.11, an IEEE standard. 802.11 is the standard that deals with everything to do with wireless networking, right? And we saw that it started off with 802.11a, it went B, G, N, AC, and now we are talking about AX. Now, why did we pick out AX specifically? Well, it's the latest standard that we have. It was ratified in 2019, so we're really 2 years away from the ratification per se, and you're already starting to see a major rollout of 802.11ax. And so, because it's the current standard, it makes sense, complete sense, to do this, to talk about this, and to focus about this. Now, if you look here on the screen, right, you can see that we've spoken about previously about networks. In course 1, we spoke about networks, and we spoke about how wired networks, cabled networks, are a full duplex medium. In other words, they can transmit and receive at the same time. Okay, so we understood that. We understood that that's a really efficient way to work. Maybe for humans it's not so efficient, except if it's Isaac's family at Christmas, where we all talk and listen at the same time. But in networks, that is quite an efficient mechanism to do that. And it didn't just start off there. It did start off with half duplex, right? So I talk, and when I'm finished talking, then you talk, and then when you finish talking, I talk. Think about it like a two-way radio, like a walkie-talkie, right? We call them walkie-talkies. I don't know what they call them around the world. But for a walkie-talkie to work, you are opening up a channel, right? Both walkie-talkies have to be on the same channel, the same range of frequency, the same band of frequencies, but it's a half duplex medium. You can't both talk at the same time, otherwise it just doesn't happen. So I talk, I let go of the button, the person on the other side heard, they respond by talking, holding the button, they talk, and I hear. Okay, that is how it started, and then it started developing to the point of getting full duplex. And part of the problem, of course, was to avoid collisions, to make networks much more efficient. But wireless networks, they are not full duplex. They are not full duplex. They are half duplex, right? And so they have to listen when they're allowed to broadcast data. Now, we spoke about bits, we've spoken about bytes, we've spoken about data, the size, of bits and bytes and all of those things. What we really haven't spoken about yet is time. Time. When a computer talks, it talks in slices of time, right? Slices of time. So it doesn't kind of give you full attention. If I'm talking to you now and you listening on YouTube, the computer is not giving 100% of its resources to YouTube for you to watch, right? Because as I'm talking to you, Outlook is still receiving your mails, right? And if you might have another browser open and you might be doing other things, and you might have a WhatsApp message open, and you might have Teams open on your computer, and so your computer's allocating slices, and those slices could be in milliseconds to all these different applications, plus all the background processes that are happening in the back. Think about antivirus, scanning, all of those types of things. So it's important to understand that not only is it bits and bytes, but we talk about slices of time. So with wireless, we're talking about a half duplex medium. And in that half duplex medium, we need, because we don't have a way to really detect collisions and to prevent collisions from happening, we have to have a high management overload, right? So if you look at this over here, you can see that in an 802.11 frame, about 60%, 50-60% of the frame size is allocated to the management of that. Only 25% of that approximately is, sorry, when I say management, I mean control. Only 25% of that is actual data. So little slivers of data that are going through, and then 15% of management. So in total, we're talking about 75% of a frame is all about control and management. A very small part of that is actually about the data, those bits and bytes, those numbers and things that get converted into zeros and ones. That's what this is about. So David, that hasn't changed in 802.11x, right? That's exactly the same.
You need the management and control traffic for Wi-Fi to work, okay? So that's never going away completely, but it does add to some of the inefficiency. So it's all about you alluded to the half duplex nature of the technology. It's at any given time, only one radio can transmit on the medium. Because of that, you need a management protocol called Carrier Sense Multiple Access Collision Avoidance. And that management protocol its main job is simply this, is to make sure that, and it's a pseudo-random protocol to make sure that everybody gets a chance to transmit on the RF medium, but everybody has to take turns. Unfortunately, that protocol in itself adds to the inefficiency, and the protocol eats up whatever your advertised data rate. And these are, I'm just rounding this off, but whatever your advertised data rate is, you could assume that the protocol in itself eats up about 50% of your advertised data rate in the half duplex medium of your aggregate TCP throughput. And I say aggregate because this is also a shared medium.
In many of the iterations before AX, the principal focus point was on speed, right? You had to introduce speed into the equation simply because look at the speed that Ethernet was going along. Wireless was really slow, 2 megabits or something per second at the beginning. So the focus for a lot of these generations of Wi-Fi standards that were released were about speed, getting the data rates up that you could transmit a lot more data. 802.11ax started to change that, and I'm going to hand over to Dave on this one. But if you remember last week, the week before last, I went out to the highway here in Cambridge and I kind of filmed the highway, and you saw the highway, 3 lanes on each side, with very little traffic happening over there. And then you saw, I showed you a second clip that had a lot more traffic. Now, if you think about time, if you look at that clip, if you look back at the clip and you measure 1 second, how many cars came past in 1 second? In the first clip, it might have been 1, maybe. And in the second clip, it might have been, say, 4 or 5 or 6. So we started to look at this and say, instead of just getting the cars to flow faster, what if we could use that highway more efficiently, reduce the gaps between the cars, etc., get them all to travel at the same rate? Do you understand? We went with this preoccupation with speed, and we went to look at it from an efficiency point of view. David, that's what happened, right, with 802.11ax?
Yeah, sure. So Wi-Fi 6 802.11ax is the first standard enhancement of Wi-Fi technology that is not necessarily focused on higher data rates. It's more of a focus on improving the efficiency and to deal with these Wi-Fi traffic jams. And it's mostly about a better use of the existing RF medium and to make things, to unplug the traffic jams. And so there's been, like I said, like you said, there's been too much of an emphasis on data rates and speeds. Yeah, we all want fast speeds, but the analogy that we use all the time, if you're going, if you have a Ferrari that can go 200 kilometers an hour, what good is it if you're sitting in a traffic jam? So you need to unclog that traffic jam, and it's to make the excuse me, the RF medium more efficient. As a matter of fact, the technology is called HE, high efficiency. That is actually the technical term for 802.11ax. Now, to your question, very quickly, it defines like 35 different enhancements. And I think in the course of your presentation here, you're going to cover some of them. Probably the biggest are on a focus on for the first time, true multi-user communications using a technology called OFDMA, Orthogonal Frequency Division Multiple Access, and we'll get into that more, but basically what it is taking the existing frequency access operations and making it multi-user instead of single user. There's also some other things like increased spectral efficiency for things like BSS coloring that we can talk about. And there's improvements to power saving mechanisms, target wake time. It's one of the differences between Wi-Fi 6 and 802.11ax over AC, for example, is that it operates on both frequency bands, both the 2.4 gigahertz and 5 gigahertz. And in the future, it will also operate as a pure 802.11ax environment in the 6 gigahertz band in the coming future. I said it's not about higher data rates. Well, I did kind of lie on that, because there is one enhancement that really does find higher data rates, and that is there's a enhanced modulation type. So QAM 1024, and I think you have slides on all these. But once again, the value proposition on all these, Isaac, is you're optimizing the existing RF medium. You're going to have a more efficient medium, and it's all about time. So instead of clients having to wait all the time and all taking turns, if you can introduce true multi-user operations into the RF environment, that cuts down in time, it cuts down on airtime consumption. And if it cuts down on airtime consumption, your users will be more happy. Their perception of the RF environment, they'll actually think things are faster, even though they're not necessarily faster. It's just that you've unclogged the traffic jam.
Okay, so 802.11ax still remains half duplex, right? That's correct? It still remains half duplex.
Absolutely, still half duplex. Full duplex would mean you have two radios communicating in two different uplink and downlink at the same time. We're not there yet. So it's still half duplex, like a walkie-talkie, where you're taking turns talking. But there's a way to communicate both uplink and downlink to multiple users from an access point at the same time. So either you can still go in one direction, okay? But as opposed to communicating with just one user, you can communicate with multiple devices. And that's the beauty of OFDMA.
802.11ax, of course, is about a lot of things. So this is one of the things we need to understand. Every iteration adds a whole host of new features. We don't just increase the speed and say, oh, there's a new generation. There's little bits and pieces that get added into this new specification. Now, I'm going to read some of them, so you'll see me read, and we'll ask David about them. We'll talk about them. First one is OFDMA. I think we're going to be talking, I'm going to ask David to spend quite a bit of time on OFDMA, because I think that is the major one. So if you were looking at overall efficiencies of 802.11x over 802.11ac and the previous standards, if you were to measure that and say, okay, here's all the efficiencies that 802.11ax brings to the table, I guess that the biggest efficiency gains would be around OFDMA. But there's others. There's the improved spatial efficiency with coloring. You might have heard about a BSS Colour. This is something that I struggled with. I'm going to ask David about that. Another one was TWT, right? It's about target wait time. This is something that's been specifically designed for IoT. Correct, David?
That is correct. So target wait time is an enhancement on the power saving mechanisms that are inherent in Wi-Fi. There's about 6 different standardized power saving mechanisms, as well as proprietary ones. The goal of target wait time is a negotiated wake up time. So think of an IoT device that only needs to send data once an hour. It can basically negotiate with the access point and say, hey, listen, I'm going to go to sleep for 55 minutes. I'll see you in 55 minutes. And if the AP agrees, there's no communication between the two. And then the IoT device goes in basically a sleep mode, and it conserves battery life. So this feature was designed specifically for IoT, but that doesn't mean it can't be used in other devices as well. So it's also supported in your smartphones and tablets and laptops.
And is that feature, the TWT, is that already embedded in IoT devices? The sensors and those things like your smartphone. Is that already embedded in there?
You have to have a Wi-Fi 6 radio. Okay, so you have to have an 802.11ax radio, and that's an important question, a real world question about pretty much most of these enhancements. You do not get the 802.11ax enhancements unless you have a new radio. So now there's backward compatibility, okay, and with everything, but your existing gear will not communicate with some of these new enhancements. You have to have a Wi-Fi 6 radio in the client devices. Very quickly, not to go long here, but it remains to be seen if we're going to see a lot of IoT devices using target wake time. I don't think that's still a little bit further out. That being said, target wake time is absolutely built into your smartphone, your Wi-Fi 6 radios that are in smartphones and tablets.
Okay, so that means that if you have an access point that's using an 802.11ax access point that's using that technology, theoretically, it could mean a better battery life for something like your mobile phone, if your mobile phone already has 802.11ax, correct?
Right, and let's be honest here. When you start talking about smartphones and things like that, they're not going to sleep for a full hour. They're going to sleep in microseconds. Okay, but theoretically, with an IoT device, it could literally go to sleep for an hour if it only needed to send data once an hour. So yes, you are getting these power saving enhancements on the client side with smartphones, but it's once again it is saving battery life, but it's usually in the microseconds. So it's still a cumulative effect.
The target wait time is obviously important, and I did say we're going to talk about OFDMA, but there's other things as well that 802.11ax you see advertised, spoken about. These are the most, I'm basically covering the most popular terms, most popular pieces of 802.11ax, the stuff that people really want to know about. Okay, so the one of those, of course, is higher data rates with QAM 2. That QAM, we pronounce that QAM 1024. So what's a modulation technique? So QAM 1024 is called a modulation technique. Okay, and it's used to optimize throughput and range. So think of it like maybe an algorithm, right? You find a way to describe something, use a mathematical formula, and you apply that to a range of data, and it optimizes that data. It optimizes within that range. If you get a better algorithm, it can better optimize that to be able to possibly, in a computer time, to optimize the calculation, to cut down on the time, to make it more efficient. Okay, so the number of points in the modulation constellation determines the number of bits conveyed with each symbol. So 802.11ax uses AC uses 256 QAM, which transfers 8 bits per symbol. 802.11ax is 4 times that. It's 1024. It is 4 times that, using 10 bits per second for a 25%. So that's what it translates to. It translates to a 25% increase in throughput. So it's not linear, it's more logarithmic. So QAM 1024, 25% more efficiency. So you see, we talk about OFDMA being the biggest slice, but then you have the next slice, and that is the QAM 1024. That's the next piece of this optimization that makes AX such a great thing, and why we say it's about efficiency, not so much just about speed, even though the perception could be that it also brings in speed, important, right? Wi-Fi 6 uses 2.4 and 5 gigahertz as well, but Wi-Fi 6E, which is an enhancement to Wi-Fi 6, that is going to be able to use the recently released 6 gigahertz spectrum. Now, not every country in the world has done it already, but the US has done it, Brazil has done it. I think it's one of the Arab Emirates has done it, and slowly around the world, governments are opening up that spectrum, the 6 gigahertz spectrum. Remember, when we talk about spectrum, it's a range of frequencies. So I just want to cover that. It's not, David, just I'll get to you, but I also need to teach a little bit over here about this technology. So what do we get in return? We talk about efficiencies. What does this translate to? Well, better traffic management. Okay, remember the highway, right? If you paint the lanes, you know. When I first went to Brazil many years ago, they had, you know, they painted 3 lanes on the highway, yet there were 5 lanes of cars. In India, it's very similar, but they don't paint the lanes always, you know, on the highways, but the same thing, 3 lanes and of painted lines and 5 lanes. But actually what you find is optimized traffic management, right? The lights work, the traffic lights work, the lines work, everybody respects it, and the traffic flows a lot better. Improvised spectrum efficiency. What does that mean? Well, the spectrum that you have, that radio spectrum that you have, the use of it becomes much more efficient, right? So if you take a highway and you say you can only travel at 20 miles per hour or 20 kilometers per hour on the highway, well, you still have 3 lanes. You can still pack cars, you know, 2 car lengths ahead of you on the highway. But it's not very efficient use of the highway and of those 3 lanes. Why? Because you're only going at 20 kilometers per hour. It's all legal, but if you take it to 60, it's much more efficient, right? So think about that in terms of radio spectrum. Think about the better use of the spectrum that you have. Overall network capacity. So again, if I need to get, you know, 1,000 bottles of pints of beer from one side to the other side using the highway, if I can only travel at 20, you know, kilometers per hour, and I can only use 1 lane, and I can only use 1 truck at a time, you can see it's going to take X amount of time. But if I use that highway as an analogy for a network, and I can have all 3 lanes, and I can have the trucks traveling each one at, you know, at 60 kilometers per hour, and not just 3 trucks, I can put another 3 behind them and another 3. What happens is my network efficiency goes up. So I can get that 1,000 pints to the other side where I need to go much quicker. I utilize network capacity much better. Absolutely fantastic. Client capacity, what the client can do, right? So it's not just about what the highway can carry, but also what the client can do. Well, the client now got bigger bandwidth, it's got more, it can be more efficient, so it can push more data through. So this really is kind of a win-win situation. Data rates, power efficiency for clients, right? So we know about that. Now we already know, David has mentioned that mobile phones, you know, the TWT on those are milliseconds, right? So they go to sleep in these milliseconds, sleep wake all the time. But you saw in the explanation that David gave, if you've got sensors sitting outside measuring air pollution, measuring you know, temperature, measuring rainfall, measuring all of that, that's run by batteries, and they have to be awake all the time, even though they send a reading once an hour or whatever it is, well, this can make it much more efficient. Those devices, those sensors, all IoT devices, are a lot more efficient. And then improved performance in dense and congested environments, which I think nowadays when we're sitting at home is not such a big issue. But, you know, get onto a London Underground, you know, get into a rock concert, whatever, and you see the performance of the wireless network just goes down. So by using these 802.11ax technologies and making use of the innovations in them, bam, you have power. You have much more ability to control this, to control the efficiency and the performance and everything are in congested environments. I like this stuff. I like this stuff a lot. All right, so let's go to the next slide, which is talking about a little comparison between 802.11n, AC, and AX. And the one thing that I've never quite understood, and I'm going to ask David if he can please explain to me guard intervals. Right? We talk about guard intervals. I think it's in nanoseconds. I've read about them, but let's ask the master on guard intervals. I think it's important to understand what this is.
Yeah, so the guard interval, think of it as like a buffer for something called the delay spread. So that is the direct effect of multipath. So multipath is an RF phenomena that it basically exists in almost every RF environment. When an RF signal is sent, it bounces around off walls and objects, and you get multiple paths of the same signal arriving at a receiver. Okay, but they don't arrive at the same time because they take different paths. Okay, if that delay spread is too, and the time differential between the different paths is called the delay spread. That delay spread, if it gets too long, you start getting corrupted data. Okay, so the guard interval is basically an not to get too complex, but it's like this, think of it as like a buffer for the delay spread. And typically this buffer is just a time buffer for in nanoseconds. That's how we're talking about how much the delay spread can fit in during this time buffer. And it offsets some of the negative effects of multipath and the data corruption. So it just kind of helps so you don't get the data corruption.
So when you look at those guard intervals, that's nanoseconds, and what we're talking about is by having a longer guard interval, that means it's a bigger buffer, so it can hold more for longer. Is that do I have it right?
It's a longer buffer. So it's interesting because within an AC, we went to an option with a shorter buffer, the short guard interval, which actually made things a little bit more efficiency. It gave you about a 15% efficiency, but in a high multipath environment, you'd still want to use the long guard interval of 800. So like if there's a lot of reflections or outdoors, to give a better buffer to make sure you didn't have the data corruption. Basically with Wi-Fi 6 and 802.11ax, the whole physical layer has been overhauled quite a bit. But one of the things is the guard interval, and there's 3 different guard intervals, and those longer ones are designed specifically more to be more resilient for outdoor communications.
Okay, so let's go to the next slide now, and let's talk about OFDM. Now, these 2 slides, or the slides that are going to be coming up, have these long terms, right? You're gonna see this in any documentation, in any training that you do regarding wireless networks, and specifically 802.11ax. You're going to see these terms, or you're going to see these terms mentioned, OFDM on AX and AC. But this is an example you're going to see in the animation, because I think the animation explains it better than me actually even talking to you about it. So this is what OFDM, orthogonal frequency division multiplexing, is. Okay, let me show you as an animation. So on the left hand side I have the access point, on the bottom I have an access point, and then on the right hand side and towards the middle you have different client devices. So look what happens. I'll set this thing in motion. So watch what happens. Can you see that it's talking to each device one at a time? So within within these time slots, these different time slots that we're talking about over here. Let's go through that again. So one time slot, the next time slot, the next time slot. It's talking to each client. Remember, this is half duplex. It's talking to each client within each time, with each one of those time slices. It's talking to one individual client. Now, it's been given a time slice, and that whole time slice is taken up by the amount of it's a fixed time slice, right? So whether you fill that by sending a lot of data or a little packet of data, it's irrelevant. You have X amount of time. So obviously it makes sense if we can either pack more data into that slice of time, or if there's a better mechanism that we can use. Let's look at this next animation here. Okay, so this is OFDM. Look at the next one. The next one is orthogonal frequency division multiple access. Orthogonal frequency division multiple access. It says multi-user. I should have maybe put that in brackets, multi-user, but orthogonal, remember, at the right angle to each other. Frequency division multiple access. Watch the difference. Did you see that? Right? Let's take that again. Look at that difference compared to the previous one. That is a really big difference. David, you want to spend some time on that with us? Because this, I think this is a fantastic, oops, let me just go back to the previous slide. I think that's a really fantastic animation, and just the concept of what it does. Go for it.
Yeah, so I mean, that's the secret sauce. OFDMA is you're going from single user communication where both uplink and downlink a client is, AP is talking to a client one at a time, where OFDMA is taking a technology that we already had, orthogonal frequency division multiplexing, and adding it to multiple access. So and I think the next couple of slides do a little bit better visualization on how this works, but it's bringing, for the first time in my mind, true multi-user communications to the technology. And you will see in upcoming slides, it's done that basically by slicing up the frequency space.
Okay, so you take a 20 megahertz channel, and under 802.11 AC, that 20 megahertz channel could, within a particular time slice, only talk to one client, right? So whether there's a little bit of data or a lot of data, whatever, within that time slice, it could only talk to the one client, like you saw previously, just to the one, to the next, to the next, to the next, concurrently within each one. Now remember, again, these time slices, we're not talking about 1 second, 1 second, 1 second. We're talking about milliseconds that is being allocated to each one. So David, take this away. I think that this is a really important slide. Take this away. I think I read about it in your dummies book. The way you explain it is brilliant. So just go for it.
Yeah, so OFDM uses what are called subcarriers or tones to simultaneously modulate data across a whole 20 megahertz channel. Okay, and it actually uses a fixed set of tones. If you're using a 20 megahertz channel, you're using all the subcarriers to modulate and transmit your data, but it's still single user. What OFDMA is different is you're basically subdividing the channel, okay? And it's by partitioning the existing subcarrier or OFDM tones. With Wi-Fi 6, there are 256 OFDM tones that can be used in a 20 megahertz channel to modulate your data. Some of them are actually for synchronization, so 242 of them actually carry modulated data. And you can still have single user communications. For backward compatibility, but also maybe for bandwidth reasons, you're going to still use the entire frequency space and use all the OFDM tones on an entire 20 megahertz channel. What is different now, what OFDMA does, that you can subdivide the channel into what I call baby channels. The technical term is resource units, where what if I could actually divide that channel in half? Think of me, I'm an access point, and what if downlink I could communicate with 2 clients at the same time, but I'd subdivide that channel into 106 carriers for each unit, which is effectively 2 10 megahertz channels. Theoretically, you could subdivide up that channel into as many as 9 different resource units for multi-user communications. However, right now, with the chipset technology that is out there right now, existing 20 megahertz channels can be divided up into as many as 4 baby channels. And this is what allows for multi-user communications between an access point and multiple clients at the same time. Just to expand a little bit deeper, the big misconception is that all the data that you're sending is high bandwidth. Yes, we're getting more and more high bandwidth applications moving forward, and we will continue to do. And when you have high bandwidth applications, you need big wide channels. But something like 70% of communications are small bandwidth, meaning are frames under 300 bytes. You don't need a 20 megahertz channel to modulate a 300 byte frame, okay? So instead of modulating a 300 byte frame, 1 user at a time, user 1, user 2, user 3, wouldn't it be much better if you could modulate 3 to 4 clients at the same time, modulate those 300 byte frames, downlink or uplink, but let's just concentrate on downlink for now, from an AP to 4 different clients at the same time. So instead of going client A, B, C, D, I can just go client A, B, C, D at the same time. You're cutting down your airtime consumption to 1/4 of what it used to be. That's what the efficiency is all about. It's taking the bulk of your communications that are low bandwidth, subdividing up the frequency space to communicate at the same time, and effectively cutting down on your airtime consumption.
So that means that you could effectively push 4 times more data in is that correct? I can push 4 times more data at the same time?
Yeah, I mean, effectively, I mean, in the same time space, yes.
Yes, in the same time space,
once again, this is not about high data rates. This is about more efficient use of the frequency space. So effectively, yes, the perception to the end user is, yes, it's more efficient because they're not waiting as long. So think of it when you're queued up at like an amusement park and you have to wait to get onto the magic goofy ride or whatever. So now you don't have to wait. What if, we could load 4 people into the ride at the same time, as opposed to you have to wait for the next train or cart to come. So it's just more efficient use of the frequency medium. So your wait time is less and your airtime consumption is less.
David, we're going to have a 10-minute break now, and we'll come back after that. So let's take that 10-minute break, like is customary, halftime. Go out, go get something to snack or whatever it is. See you on the other side of this.
So last weekend I went out on a bike ride and I stopped off at my local train station because I wanted to show you something. This is a typical train station in a small town or village in the UK, in England. You can see there's a ticket office, there's a car park, pretty big car park. There's a lot of people that commute into London or would normally be commuting into London, but it's pretty quiet, it's the weekend. So you see there's not many people around. You can, we can get a train in that direction and get up to London in just about an hour. The train goes directly into Charing Cross station right in the west end of London. And if you go the other way, about 45 minutes down to the coast to Canterbury and Ashford. Now, I wanted to show you the trains. Now, these are electric trains. They're pretty clean. In fact, they're very clean. They're efficient. They don't break down. The service is good, maybe a little bit expensive, but it's good. And recently these trains were refitted with Wi-Fi, so there's now a Wi-Fi network on the train, and especially on the part going up to London, there's quite a lot of tunnels. The railway line goes down into cuttings, so real challenges from a wireless and radio wave propagation perspective. So just think about that. Think about, we've been learning from Isaac about radio waves and how they travel. Imagine trying to build a wireless network on something, like a metal tube on a train or a plane or in a ship. These are the real world challenges that you're going to face when you're working as a network engineer, as a wireless engineer. You've got to understand these really challenging situations, and I just wanted to show you that because I think building wireless networks in transportation is one of the most exciting things that we're doing, and you'll be doing. So I'm back out on the road now, riding back to back home. But I just thought I'd show you that. Have a think about that. Have you got Wi-Fi on your local transit system? Is it working well? Is it not working well? Have you worked on something like that? So do you know somebody who's working on one of those projects right now? Put it in the chat window. Share some of your stories of what your experience is as a user or as an engineer. Share that with the rest of the team. So this is the countryside where I live. A couple of things to look out for. Look, it's springtime now, but the leaves on the trees haven't come out. So look at these really big trees. They're oak trees, and because the leaves aren't out, you can really see the amazing and intricate branch structures. Now these trees live for hundreds and hundreds of years, and some of the big ones are already a few hundred years old. So they're fantastic. Fantastic trees. And also look out for the hedges or the hedgerows. You'll see on the left and the right, this is where the trees have been cut every year, so they grow horizontally rather than vertically, and they form up natural boundaries to the fields and are great places for nature, so for small animals, for birds to nest, and the landowners and the farmers, they really take care of these hedges. They have to. It's legal here that you have to take care of these hedges, especially the older ones. They're protected, and they're the ones you can see here. They're hundreds of years old as well. So enjoy. Hope you're enjoying the break. Enjoy the countryside.
Okay, so let's build out let's go to the next one. Let's go to the next slide, because let me just hand over this slide to David and let him just go through the whole thing, because it's kind of a continuation. David, take this slide from here and go through the animation on this one. Explain to us exactly now about OFDMA and these raw resource units and how they differ from what came previously. We've spoken about this before, you and I, and your explanation is brilliant. So I'm not even going to add anything more. Just go for it, David. Take it out the door.
Yeah, so absolutely. So this is basically a visualization of a 20 megahertz channel, okay? And it consists of 256 subcarriers. Now, with previous technologies, you could only, an AP could only transmit downlink to a client using all the subcarriers at once. But what if you could do this? What if you could divide it up and the AP could transmit downlink to 2 clients using half the subcarriers to one client and half to the other? And then what if you could do this? What if you could subdivide the frequency space up into 4 using 4 baby channels? And now I'm transmitting downlink to 4 clients at the same time. What if I can, now I can still use this 20 megahertz channel and communicate downlink. Maybe I have higher bandwidth needs to one client. So I can still, and this is also needed for backwards compatibility. I can split up the channel again in 2 or 1 or various combinations. So I like to call these baby channels of subdividing up your frequency space. But as I mentioned earlier, there's actually a technical term The subdivision of these subcarriers within a channel is actually called a resource unit. And it's all about resource unit allocation. The AP allocates the resource units to the clients, both uplink and downlink. And with that resource allocation, communication, it can then subdivide up the channel and then cut down on your airtime consumption.
So all of this work that you're talking about, all of this is then handled on the access point side, right? The access point is doing all of this, and 802.11ax access point is doing all of this. Is that correct?
Well, the client has to understand it. Okay, let me put
Sure,
it that
sure.
way. So
Yeah,
you're
yeah.
going to need AX clients will have to participate in multi-user communications. The AX clients will to speak OFDMA, think of it as like an enhanced language. They'll have to understand the language. But the resource unit allocation is done by the AP. For downlink, it absolutely does it. It subdivides up the channel. It gets even more complex for uplink. I don't know if we get into that in great detail in this session, but there is what is known as synchronized uplink OFDMA. That does require a feedback loop from the clients, where the clients actually will use something called buffered status reports to indicate to the AP what kind of data they need to send uplink. And then the AP can arrange for a synchronized uplink with multiple clients, say 4 clients at the same time, but will once again make the decision on how the channel is subdivided. So the AP is actually in charge of all the RU allocation. I will say this, one of the biggest questions I get is, do the rules of medium contention change? So at any given time, all clients have to contend, use that pseudo-random protocol I talked about to contend for the medium. At the end of the day, the AP still has to do what's called has to win what's called a transmission opportunity, TICSOP, and contend for the medium. So it still has to use carrier sense multiple access collision avoidance, win the medium, and when it wins the medium, that's when the AP can actually control it for either uplink or synchronize. It's either downlink multi-user OFDMA communications or synchronized uplink communications.
That one hurt my brain a little bit. Take it easy, David. Okay, I'm gonna have to go and watch this the recording again to get that. I think I understand what you're saying. I think if I go back to this next slide, I think this slide kind of illustrates graphically, right? Academy style, illustrates what you're trying to say. Basically, that on the left, OFDM, for each slice, for each time slice, it could only talk to one client. Okay, so I think that's what you said, that what I understand. For each time slice, you could only talk with one client. So if you had a lot of data, a little bit of data, it's irrespective, that time slice is allocated to one client. But with OFDMA, during a time slice, you can talk to multiple clients, up to 4 at the same, I think that's what you meant, up at the same time, right? So you can talk to 2, you can talk to 3, you can talk to 4, or for backward compatibility, you could talk to a client, to an older client, right? So you can have the AX technology and it can still talk to an older client that can only understand talking the whole 20 megahertz on that one particular channel. Have I got that?
It's all about airtime consumption, and making a better use of the frequency space, and that's what OFDMA is all about. It's nothing new. It's taking a technology we were already using, OFDM, and making it from single user to multiple user. And by the way, this is time-tested technology. You've been using OFDMA technology in your LTE phones now for a number of years. So it's just been ported down to Wi-Fi with Wi-Fi 6.
Who invents the technology that eventually makes its way into our access points, right? I mean, is it engineers from Extreme? Is it the people who create the the baseband chips. Who, is it a bunch of engineers from around the world that get together and just sit around a table and hash this out? Or is it volunteers? Like, so I want to try and understand who invents the stuff, how are these standards kind of created, and the agreements and that, kind of, do you get my point? Do you understand what I'm asking?
Yeah, so that's a very good question. So there's two bodies that are of importance: the IEEE and the Wi-Fi Alliance. The IEEE is the engineers that get together and make standards for everything, not just technology. They make standards for how to brew your tea. Okay,
Yeah.
I mean, you can look it up. There's a standard for everything. But it's all about enhancing, our way of life. And a lot of it, though, is standards for technology. So the IEEE is always working on these standards on how to improve Wi-Fi. So the 802.11 standard is very specific for wireless local area networks. And it is engineers. It is a bunch of geeky engineers that get together and they come up with these brilliant ideas on how we can make things better. But to be honest with you, it's the other organization that's of more importance for how all this works, and that's the Wi-Fi Alliance. The Wi-Fi Alliance has two missions. Number one, they're the marketing wing for Wi-Fi, but number two, they do the the compliance, or I should say the testing to make sure that all the stuff works together. So to make sure that if you have an extreme access point deployed, that your Apple iPhone or your Samsung Galaxy device will be able to use these technologies. So all the major vendors, both on the client side and on the vendor side, they have to get their equipment tested and certified by the Wi-Fi Alliance. Wi-Fi 6 certification basically has taken a lot of the key components of the 802.11ax standard from the IEEE, and they're defined in test labs of certain things that they have to abide by. So for example, I alluded to OFDMA and the use of 4 resource units. Pretty much everybody has to prove that their radios can do up to 4 resource units on a 20 megahertz channel. So there's a whole list of things that are tested in what's called a test bed at these independent labs that do the testing, and then we get the certification. So it's all about interoperability, and it's very, very important, because if we didn't have these certifications and the interoperability, there's a good chance a lot of this stuff wouldn't work. So and not to go long, but I will say this: it's kind of interesting, because I am Extremes rep to the Wi-Fi Alliance, and I deal with a lot of engineers there that are way smarter than me. And at the end of the day, a lot of them are also the same engineers that are in the IEEE. So once again, you start with the standards, but it's the interoperability certification testing which takes components of those standards and validates them. And that's where I like to say that the Wi-Fi Alliance for the average user is probably of more importance.
So David, sometimes on our company meetings, we hear people say things like the access point has been submitted to the Wi-Fi Alliance for certification. Okay, so when we submit an access point to the Wi-Fi Alliance, and it goes through the whole process, the testing, the making sure that it complies with all the standards and rigorous disciplined process. So I know it takes quite a long time to get these certifications, and you got to pay for these certifications and all of that. But if I'm a consumer, okay, or maybe even an organization, but if I'm a consumer and I've listened to all of this, I've watched these YouTube videos, I've listened to all of this, and I'm like, yeah, I want to get access point, and I pick up an access point. How do I know it is Wi-Fi 6 certified? I mean, what stops me from putting a sticker on it, for example, just say Wi-Fi 6 certified, or, so I'm trying to figure out here, and I'm trying to put myself in the feet or in the shoes of the viewers who watch. How do they know? Is there a sticker that goes on? Can they, for example, go on to the Wi-Fi Alliance website and go there? Can they ask, by company or by product or? So what I'm saying is, how do I know a product I buy is genuine Wi-Fi 6 certified by the Wi-Fi Alliance? Is that can you tell us about how that whole thing works?
So almost every vendor will put some sort of sticker or with the Wi-Fi with the certification logo on their boxes. Okay, if not on their data sheets. So excuse me, we spend a lot of money. And Wi-Fi 6 is just one certification. There's many certifications. There's WPA2 and WPA3 for security. There's WMM for quality of service. A lot of times they're dependent on each other. I can't get Wi-Fi 6 certification unless we also support WPA3 and WMM, the two I just mentioned. So bottom line is every vendor is going to put this on their data sheets. Typically we'll have the Wi-Fi Alliance logo and the certificate information very often on the box. And of course, you can always go to the Wi-Fi Alliance's website. It's wifialliance.org. And you can search for any certified device. There's a database that anybody and everyone can search to see. And it's very easy to use. I will just say this, be careful sometimes with some of the consumer grade stuff. Sometimes you'll see like this little fake logo that's made to look like it's certified, but it really isn't, But for any enterprise vendor, most enterprise vendors are going to get their stuff certified.
So that Wi-Fi Alliance, is that Wi-Fi Alliance one word, or is it is the Wi-Fi hyphenated?
You would ask me that. I think it's Wi-Fi hyphenated. I think it's Wi-Fi hyphenated. Wi-Fi Alliance .org. Google's your friend, dude.
So the next the next slide is the title is OFDMA versus multi-user MIMO. Okay. I've heard you talking about multi-user MIMO. Bring us. I don't want the point-by-point comparison or whatever. Kind of give us your thoughts on OFDMA versus multi-user MIMO. I want to know. Tell our audience what you think about this. Don't worry about having to be rigorous with the slides. Just talk to me.
Yeah. So truth be told, there's actually two multi-user technologies defined in Wi-Fi 6, OFDMA and multi-user MIMO. Downlink multi-user MIMO was first introduced with 802.11ac. It's very complex technology and it's pretty interesting. It's and this multi-user MIMO is used in a lot of other RF technologies as well. The short end of the stick, the short explanation, I should say, is multi-user MIMO is completely different. It's not subdividing up the frequency space. It's taking advantage of the fact that the AP has multiple radios and antennas. And what you can do is modulate downlink independent spatial streams to different clients.
Just say that again, slowly. Modulate downlink spatial streams.
Yes. So instead of by using like if you have like a 3x3 by 3 AP or a 4x4 by 4 AP, you effectively have what are called 4 radio. If it's a 4x4 by 4, you have 4 what are called radio chains, which is effectively 4 radios and 4 antennas. And using those together, you can modulate different data streams, different streams of data that are unique to each client. You're still using the whole channel. Okay, so you're still using you're not subdividing up the channel, but at the same time, you can uniquely send different unique data to the different clients. It's actually very cool technology, but it basically indoors, it requires a pristine RF environment. It basically requires the planets to align. You need what's called spatial diversity. The clients have to be have a lot of distance between each other, 10, 15 feet, and there also has to be distance between the clients and the AP. And pretty much if they're mobile, it doesn't work very well as well. So if you don't have that spatial diversity and distance between each other, they can't distinguish between the independent streams. So I'm going to be very honest here. Multi-user MIMO has been hyped quite a bit, but it's very hard to get it to work, especially in high density indoor environments that, pre-COVID at least, we were very used to. And one advantage it does have to have over OFDMA, it can really it's a great multi-user technology for high bandwidth applications. So there are some advantages to it, but once again, it's hard to get it to work. To me, the best use case for multi-user MIMO is point to multi-point bridging in an outdoor environment where you have like one building that with a multi-user MIMO bridge that is then communicating with 4 other buildings.
Gotcha.
That's for and so you have that spatial distance between the clients, and you also have the stationary where everybody's stationary, and it works. So there's a lot of vendors that are using multi-user MIMO very successfully in that type scenario. To me, OFDMA is at least in typical Wi-Fi environments is going to be used more often or not. Now, in reality, they can both be used at the same time, or and by the way, every radio, Wi-Fi 6 radio, supports both. Okay, but the efficiency enhancements that we're going to see for the most parts in most standard indoor environments probably going to be more from OFDMA than multi-user MIMO.
Sure, there's a lot to think about. David, we're coming to the end now. I think I got 1 or 2 other things that I wanted to ask you, but one of the things I did want to ask you is the usage of Wi-Fi. If we categorize it into indoor and outdoor, okay, I think in my mind, and it's possibly because of COVID and most of us are kind of stuck in our homes or whatever, would it be right, is it correct to assume or to say that the biggest usage of Wi-Fi, if you looking at it from those 2 categories, indoors or outdoors, would it be fair to say that it's indoors, that the majority of usage of Wi-Fi is still indoors rather than outdoors? I know it's a bit of a moot point and probably really difficult to measure, but your thoughts?
Yeah, I would say that, but Wi-Fi's, it's ubiquitous. It's everywhere now. It's become part of our culture. It's in stadiums, it's in outdoors. If you think, like you said, in a campus environment, they're still going to provide outdoor coverage for their students, for example.
Yeah.
And you're starting to see outdoor coverage being used more and more in public and government type spaces and parks and things like that, marinas and things like that. And we do stadiums here at Extreme Network, which are mostly outdoors, and we're the official Wi-Fi provider for both here in the United States, both for the NFL and Major League Baseball. So and those are mostly outdoors as well. So there's still you do have Wi-Fi is. To me, it's everywhere, but I think that is a fair statement. You're probably using Wi-Fi more indoors than outdoors, but that I think is changing. You're not going to be you're not going to be communicating with your home Wi-Fi when you're driving in your car. Let me put it that way. So.
Yeah, it's kind of like when I was last in Singapore. It's kind of, I mean, Singapore is an amazing place, but it kind of doesn't matter where you are in Singapore. You have not only a good cellular access, but you have Wi-Fi everywhere, and kind of you don't even pay for it. It's like bus shelters, taxi ranks, because so much of the stuff is all done. Calling a taxi, it's all done. With a smart device, smartphone, whatever it is. Wi-Fi is really, really ubiquitous, and yeah, I know Singapore kind of leads because they technologically ahead of the rest of the world, by far actually, but I mean it's really becoming ubiquitous all over the place, right?
Like I said, it being used more and more and more for public access as well, especially in Europe. There's a whole initiative for that right now. So
hold your horses. It's that time. 60 60 seconds. Get up off your chair if you've got an Apple Watch and you need to walk around to get your hours thing in, exercise in. Go and walk around. You got 1 minute to stretch, stand up, do whatever you need. Get out of that chair. Come on, do a stretch. Join us. You can sit in front of your computer and do the stretch and watch what the crazy people do on this. See you after this. I love these 60 seconds. Every time I watch one of these, it's getting more and more, more and more crazy. Fantastic. Let's get back to the training. Let's go to the next slide. There we go. This is another one, David. I promise we are coming to the end. This one is, I just don't get it, right? I think perhaps it's the term BSS Colour, and our slides always have colour on them. I don't, to be honest with you, I don't understand this term BSS Colour. What is this about? Please make it easy for me. Make it easy for our students. I'm sure many of them know, but there's going to be other people like me who don't know. And they're like, what are you talking about? We know waves don't come in color, whatever. David, make it simple. Help me to understand so that I never, ever forget again. And I'm able to explain what is BSS Colour.
So let me give it to you in a very high level. So one of the biggest problems with Wi-Fi is what's called co-channel interference. I don't even like the term co-channel interference because it's really just Wi-Fi working the way it's supposed to work. There are thresholds, RF thresholds, based on the medium contention protocol to make sure that any given time nobody else is transmitting on the same channel. So in other words, if I'm an AP on channel 6, if there's another AP on channel 6 nearby and I can hear that, if that AP is transmitting, I have to defer, okay? Because we can't transmit at the same time because you'll corrupt the data. So basically what happens is everybody defers if they're on the same channel and they're within listening distance of each other. It's the same thing with clients. That's actually the dirty little secret. The number one cause of co-channel interference are clients. When a client's transmitting on channel 6, if there's 3 APs nearby on channel 6 as well as other clients, they have to defer. It's a listen before you talk technology. And we could go into a lot deeper dive into it, but basically co-channel interference is just Wi-Fi working the way it's supposed to work. But in the 2.4 band, there's only 3 channels, okay? So you're always gonna have co-channel interference. And even at 5 gigahertz, there's only, if you're not using the DFS channels, for example, you can still get co-channel interference, where basically it's wait time. So it's not really interference, it's consumption, unneeded use, it's airtime consumption, and simply due to the fact that you have nearby ABs or clients in the same channel. Now you can avoid it with proper design in 5 gigahertz, but it's impossible to avoid in 2.4. Very quickly, what BSS Colour and spatial reuse operation is trying to do is mitigate co-channel interference. So BSS Colour is simply a numerical identifier that identifies a separate basic service set, which would be an AP and clients communicating with it. And based on that numerical identifier, you could actually have APs and clients on the same channel, like in the example right there on channel 36 in red, that might be able to do adjustable thresholds for RF sensitivity, and maybe even in some cases allow for if there's enough physical distance between each other, still be able to transmit at the same time. Transmit at the same time, even though they're on the same channel. So the one in red and the one in blue, those are different identifiers, but because they have enough distance from each other, even though they can barely hear each other, they could probably they can loosen up their thresholds for deferral and transmit at the same time and not corrupt each other's frames. This sounds wonderful. Most Wi-Fi geeks like myself love the potential of this. To be honest, though, I think it's going to take a while before we see this actually working very well in a production environment. Okay, every client supports this. Wi-Fi 6 client and AP supports this, but getting basically these dynamic clear channel assessment thresholds to adjust based on this color number, I think we're not quite there yet. And I'm just being honest.
So the bottom line impact on this is, like I spoke about, the pillar of efficiency, all these things that make up 802.11x, make up that thing that we say it's much more efficient than just about data rates, how fast it is. It's much more efficient, right? If we talk about this BSS Colour, it's part of those slices of improvements that is made to that standard, that makes it better, right? That makes that standard better.
It's all about cutting down on wait time and having better airtime consumption. So a better use of the existing airtime, so that and that's what it's all about. In theory, this sounds wonderful. Practical implementations, I think, are still a little bit out.
David, 802.11ax is where we are now. It was ratified in 2019. So we are starting to see more and more devices coming through. Only recently, though, Apple, for example, only their devices, hardware, I'm not talking about mobile, so computers, laptops, that type of stuff, only on the M1 processor, which was released, just a few months ago, is running AX. Everything else is still running AC. What I'm saying is I'm guessing that it's still going to take time for all manufacturers, etc., to start putting it in. I'm not sure, how the rest of the stuff is. I don't really know much about PCs and that kind of world, but I'm imagining that even with Extreme, we now, are selling, we got a range of AX access points, and that's what we're selling, because it makes sense, right? If you are upgrading a network for a school, for a hospital, for a college, for a district, for a government, why would you today go and put in AC devices, right, when you can get all the additional benefits of having AX? It just makes so much more sense. The standard is going to be, in use for another 4, 5, 6 years possibly. I don't know how you think about it. So that's kind of one thing I wanted to ask you about. The other thing was, what's the future, right? I know you're on the Wi-Fi Alliance. You're part of, you represent Extreme on the Wi-Fi Alliance. I'm not asking for secrets or anything like that, but what I'm asking is, when I say secrets, for things, that that you're not supposed to reveal. Oh, that's what I mean. But what I'm asking is, there must be, the day they ratified 802.11ax, they must have started on that day, already started to work on the next evolution, the next stand. I mean, is it Wi-Fi 7? 802 what? Do you know anything about some of the, what are people talking about? I mean, engineers, you go to meetings, you have, Zoom meetings or whatever. What can we expect, down the road, 5, 6, 7 years? I don't know. Can you give us kind of an insight into the future of Wi-Fi, what we're doing or what's going to be happening?
First of all, just understand that Wi-Fi 6 is going to be around for a while. So if somebody's buying an access point or a client right now, they should look for the Wi-Fi 6 logo, okay? There's really no point in buying older technology. I will take issue to what you said. One thing that you said is most of the clients that are coming out now are Wi-Fi 6 compatible. Not everything. So like, for example, that you'll still see some vendors that come out that are still using AC technology, but for the most part, most clients that are coming out are Wi-Fi 6. So it's all about future proofing, and it's always about buying the latest and greatest. This is a question I get asked all the time is, oh, why don't I just wait for the next version of Wi-Fi? Well, the analogy is like this: there's always going to be something new on the horizon. Okay, so like you buy a new car, you buy a car in December. You buy the New Year's model, but you know what? As soon as you buy it, they announce the new models. So, this is just the nature of the beast and the nature of the technology, and not just Wi-Fi, okay? So there's always something down the road. Keep that in mind. Wi-Fi 6 was a pretty big shift, okay? Because we went for the first time from a single user to a true multi-user communications. And we touched briefly too that Wi-Fi 6 is also coming to the 6 gigahertz frequency band. And you'll be hearing more and more about that in the coming year or two, 6 gigahertz and Wi-Fi 6E, which is just AX in the 6 gigahertz band. So that technology is the technology that's solid for at least another 5+ years, okay? That being said, there is something called 802.11be that the IEEE has as a draft, and it hasn't been established yet, but more than likely the Wi-Fi Alliance will probably call it Wi-Fi 7. That hasn't been done yet, so people are speculating that, but it kind of makes sense that that's probably what will happen. And basically what it'll be is it'll expand even more things on what we already have. And it's a lot of pie in the sky stuff, okay? They're talking about really even bigger channel widths of 320 megahertz. I think that would be probably mainly be used for point-to-point communications. They're also talking about multiple AP capabilities where a client can actually be communicating with 2 APs at the same time, maybe downlink from one and uplink to the other one. Yeah, so they're talking, which would effectively give you what, full duplex, right? And then there's a lot of other things that, they're even talking about, 16 APs that could be 16 by 16 by 16. I'll make an argument all day long that 4 by 4 by 4 is more than enough. Plus most clients are 2 by 2 by 2. But, so, there's, but there is more of an enhancement on throughput again. So it's called extremely high throughput. And so it's going back to not just efficiency, it's going back to future throughput enhancements. And already we're starting to see augmented reality and virtual reality starting to become a potential application that is used wirelessly, but it's a bandwidth hog. I think you'll start seeing that first in the 6 gigahertz band with 6E, but Wi-Fi 7 also holds potential for even ridiculous throughput rates of theoretically up to 60 gigabits per second. That would be if the stars align. But you're talking some incredible speeds and throughput. So that's kind of the goal, is more of an emphasis back on throughput and some efficiency enhancements. But a lot of this is pie in the sky stuff. None of this is decided, and a lot of this can change. And it's, in my mind, it's probably at least 3 or 4 years out. Tactical implementations of Wi-Fi 6 are going to be solid for 5+ years, okay, and longer, quite frankly.
On the inflection points podcast, the last one, I think it was episode 4 or something. was a really, really good one. I don't know if you listened to the podcast, but they were talking about how consumers drive drive technology. You want to use it that, and it kind of, if you think about gaming, for example, the the way that graphics cards, I mean, I remember the time I used to buy a graphics card and it was the choice whether you had, with 1 meg or 2 megs. That was the choice of onboard memory. Today these things are huge beasts and incredibly powerful. So there's a perfect example of how an industry within computing, the gaming industry, for example, has pushed the envelope on what is now considered standard for a gaming rig, right? They've really pushed that envelope, and the graphics today that you get are absolutely, incredible. But I can see in this world of wireless, I mean, when I was in Singapore, I was talking to one of the guys from one of the big telcos over there, and they were saying, oh, I was commenting because I saw billboards, that you could get 10 gig to the home. I think it was 10 gig to the home, internet access via fiber, and I was like, what? Why do you need 10 gig? And I remember I remember the moment, I remember the time exactly. He looked at me like I was from another planet, and he said, virtual reality? He said, if you're going to do virtual reality, you need massive bandwidth to do it properly. And, my mind just blew, just like, wow. I thought I lived in a first world country. Wow. It blew my mind. But I can see how this desire, this drive from people, for example, that want, virtual reality, augmented reality, all of these things, how they're not going to want to be tethered, using an Ethernet cable. They're going to want to take their laptop and have that type of bandwidth, where everybody in the office is doing virtual reality stuff. And maybe COVID is the thing that's driving us to that point, virtual presence and all of that. But how do we handle that type of stuff in the future of Wi-Fi? What do we do?
Yeah, I'll be retired by then, but I will say this. You did point out there is a concept called the consumerization of IT, where consumers basically force the enterprise to deal with the technology. And historically, that's how Wi-Fi got it started. Wi-Fi was a consumer technology initially. I mean, it was used in the enterprise in the early days in like warehousing environments, but that was about it. But it found its way in consumer grade products back in 802.11b, right after the turn of the century. And people liked it. They liked having that wireless freedom at home. So they basically demanded having it at work. And, enterprises pushed back initially because Wi-Fi was not secure. But in time, basically the employees and their consumers force their employers to bring Wi-Fi into the workplace. And now, of course, now everybody has it, and there's all kinds of benefits of providing that mobility in the workplace, because it makes your employees more productive. So, and look, a thing I always say is that Wi-Fi is ingrained in our culture. 21 years, been around 21 years. 21 years ago, you didn't even know what Wi-Fi was. Nowadays, everybody knows what Wi-Fi is, and everybody uses it, and most people can't live without it. I mean, most people would be willing to give up their firstborn child if they could continue to have Wi-Fi. So I know that's an exaggeration, but probably not a good analogy. But bottom line, it is ingrained in our culture, and it's going to be around for a long time. there's other technologies like 5G and stuff. If you'll hear lots of things about like hype about how 5G is going to replace Wi-Fi. That's not true either. The technologies are complementary to each other. So there will be room for other RF technologies and cellular, and there's a lot of blending of these technologies as well. So I see Wi-Fi being around for a long time. And like I said, it's ingrained in our culture, and people are going to use it at home and they're going to use it at work.
Brilliant. Absolutely brilliant. I hope you enjoyed that session with David Coleman. It was the first time I've done an interview like this. I hope it came out okay. Wonderful. What a fantastic guest. What a knowledgeable person. What can I say? Thank you for watching. Thank you so much for giving us 2 hours of your time again today. There's going to be no homework this week. There's a lot of stuff to go and watch again, to think about. I'm excited, you can tell. Have a great week. See you back next week, same time, same place. Cheers.